Alright, draft physics video production. I was doing some thinking. Yes, I do that. And realized that there might be there's different ways to interpret or perceive or, well, model something. I mean, you can get the same result with different ways of doing it. And I'm thinking that maybe I've been wrong about an element of this transfer of momentum, the way it's captured. And it goes back to the simple argument I made quite a while ago, where you can sort of understand that in a universe where there was like stuff and it hit each other in pure kinetic fashion, that is, this object went the direction this one went, a pure reflection, and this one goes the direction this one was going. And essentially that would be a pure kind of kinetics. And that in that pure kinetics, in a universe that would be made that way, just in reference to Hothliday, a little memorial to his input, it was a conversation with Hothliday where there was sort of this argument made is that there's a problem with a universe made out of an ether, let's say, that was active, in that if it worked purely kinetically, even though something was happening, nothing would happen, in the sense you wouldn't be able to see anything, because what comes in ends up going out. The system is kind of, in that sense, closed, in the sense that nothing new can really happen, because things are just exchanging. One thing is going the same way the other thing was going, and the other thing's going the way the other thing was going, and nothing, you can't tell missing from hitting. So nothing can happen. But if I change the colors, that is, if two different colored things hit each other, well, then you can see the interaction, because now the green thing is going the opposite way when they hit, and the blue thing's going the opposite way. And so now the universe of a miss has the green going this way and the blue going this way. So now the miss, okay, this would be the miss. Now the miss and the hit are different. You get a different outcome. The universe does change. So thinking about that, I was just thinking about the fact that I had considered in the past the idea that the boat, so going to the boat analogy, so you have to have some familiarity with the stuff I've talked about before to understand this video. But the idea is that you'd have a boat, and the people in the boat, would be a certain color. All right, and my exchange idea was like that's what was taking place, is that somebody thinks something would come in and take his seat, and then he would leave. Now, obviously I wasn't doing that with some exchange of a shirt color, so I would still argue that that's not what really is going to happen. And so if we think about the interaction just being a collision, all right, that the thing collides with the other thing, so now we're back to having the real result is the same guy is sitting in the seat, and all that's going to change is what direction he's going. So this guy was going this way, let's say. You hit him, and he's just going now the opposite direction. You hit him head on, and you're going the opposite direction. And so you get the idea of the reflection, but you don't get to change what's inside. You don't change who's sitting in the seat. You just change which way he's rowing, and you're going his way. So it's perfectly conservative in terms of conserving momentum, but it does make it a little more challenging for your imagination, but it's simpler. That's the funny, ironic part. So for the people doing simulations, the change would be that you don't have to worry about this perpendicular thing, in a sense that the idea would be is that the opposite force is now going to do the reflecting. Okay, so a green thing is going to hit, the green thing is going to reflect, and what happened inside the boat is that something going this way is going to also reflect. So the action has the two components. These two things hit, there's a reflection this way and a reflection this way. So this thing's momentum is going to be changed, because the same way, in the sense that something that was going this way is now going to go that way. So you have to add those two vectors, for the total distance will be this. amount of change in momentum. So that stays the same. And there's a reflection, which is sort of the same. But the idea would be is that when the same color comes in, it won't do anything. You know, the guy in the seat's going to stay in the seat, and you're not going to exchange momentum in that sense. It's just, you know, the guy leaving will now leave in the direction the other guy was rowing, and the rower will end up. The point is you just have to imagine it's the same will go in as was out, so you're not going to change anything. Is the point. This guy will take the seat, but his momentum is going to be the other guy's momentum because he's exchanging his momentum. So this guy jumps into the seat, but he has the momentum of the guy he's exchanging with, and the guy leaving the seat is going to be leaving with the momentum he had. So this momentum is going to leave. That's going to be the end result, is the momentum is going to leave in the same direction, and what's in the boat's going to be the same too. So there's no change. So it's like as if, you know, in the pure sense of a kinetic reaction, it just went straight through. It missed. Nothing changes. So it's like it goes right through. Now it doesn't go right through, but it's as if it went right through. You can't tell the difference between hitting and missing in this circumstance. Right. So there's no change in this thing's momentum because the guy in the seat is the one going to change his rowing pattern. He's going to row the direction that he was rowing. Yeah. It's because it's a new guy, but he has a new rowing direction. But his new rowing direction is the direction of the guy he's replacing. So you replaced the rower, but you didn't replace the direction because he took the other guy's direction. Well, anyways, it's no change. So you don't have to worry about perpendicular. Now, I would argue it's still relevant in the sense that which way these angles hit will, in some circumstance, matter. I can't think of how it would matter yet, so let's just pretend we're not going to worry about it. It still has to do with momentum. Yeah, that's right. So the momentum of the overall thing will dictate how likely it is for you to hit somebody opposing you versus somebody who's going in the same direction as you. So your likelihood of hitting something increases or decreases, and that would probably be the relevant factor. So the faster it's going, obviously you can't catch up to it. Your rower won't hit it, and your rower coming in the opposite direction has a more likelihood of having an interaction. So what's going to make the decision about whether there's an action, which really isn't an action anyway, so it doesn't matter, really, it doesn't, just forget about it for now. Alright, so that's, so let's try to redraw the interaction between two objects with the new rules that are just as simple. I mean, even one stage simpler. I mean, it's still two effects. You still have the pure reflection, and you have the transparent deflection. It's not even a deflection, it's just a transmission, essentially. So the idea would be as a green comes in here and it reflects, and this thing's momentum changes. So the same effect would happen here in the sense that there was something trapped in between these two, right? If it was a green, it would reflect, but if it went back to a green, it would go right through the green. So now it's gone. So there's no energy trapped here. And there's also no way for a green to come in here, okay, without reflecting. So we still have this shadow here. Like there can't be any greens getting in here. So this space between these two would have to get rather sparse because there's no place for a green to get in and there's no place for a blue to get in. So no blues can come in this way. And anything that's in here is going to leave. So you're going to have strong attraction. So it looks like attraction is going to work fine with this model. Now, the other trick is now if I put something that's the same polarity, you could understand that if there is any green in here, it's stuck. It's just going to keep bouncing back and forth, back and forth, back and forth. and so you got this strong reflection, so you got your repulsion. So you still have, and obviously if there was another green here, these two would, the blue force would end up trapped between it, so you'd have a lot of blue trapped in between here, and no way for blue to get in except for when they change positions, then new blues could get in. But that's the other part that's a little bit tricky, is what the rules are of a reflection. If something hits the bottom of the boat here, the idea is does it reflect out here, out of the center of gravity? And that's sort of the argument. So technically you could hit here and you would reflect back at the center of gravity, and that would contain the force within the object, because it wouldn't be bouncing. We can't presume the existence of these circles. Assuming that the objects are circles is just an assumption. But anyway, it looks like that rule will work. So I find it a little bit annoying visually, just because I'm so used to the other model. But the rule is the two reactions that happen, and so you just invert it for the green object. So when the the red force, I'm just using these colors because I'm running low on the other colors. I gotta get more dry erase crap. So the opposite force reflects, and the same force, for the time being, I'll say, goes right through. And this also works, I guess, in the sense that, let's say we do make a dipole, that is, two of these things get very close to each other, then the rule would be that it goes straight through. So then you would have all the blue energy going this way would still come out blue. All the blues coming from the external world would come out blue. So you got those reflections. And the only question is, what happens to something coming in this way? Is you tend to want it to come out this way. But yeah, it goes straight through. So this will go straight through and come out this way. So all the energy that comes this way will still come out blue this way. This blue goes straight through. And now that they're connected, it doesn't bounce off of here. So you don't think like, oh, it's blue, and now it's going to bounce off the green. It doesn't bounce off the green when they're connected. It goes straight through. And so that'll create the syndrome where you have all the blue crap coming off the blue side of the magnet, and all of the green crap coming off the green side of the magnet. So the only thing that's really, all you're changing is the boat is got the opposite sailors in it, but it's really, this was probably the right way to do it from the beginning, and so the story should have been this way from the beginning, and so this would have been so the story should have been that the color of the boat color is the opposite of the sailor color. Well, you really don't want to do that, right? So I want to say that these are all blue guys inside the blue. Okay, all these registers are blue, and all you're really saying is there's a pure reflection. That is, the guy in the seat takes this guy's momentum, he moves the new direction, and this guy's the swimmer, okay, takes on the new direction of the rower. So essentially it's like the swimmer comes up to get into the boat, and the rower hits him with his oar. The oar swings around, hits him right in the face, the rower, so he goes in the opposite direction, and the swimmer, just being hit in the face with the oar, goes the opposite way, something like that. You have to make up some story of the reflection to make it metaphorically stick, but but this is the idea. So those doing a model, maybe try this, and then you won't have to worry about this, why does the opposite color do some kind of bending thing, because now it won't do that. You don't have to worry about the perpendicular, because it sort of takes care of itself by just making it a straight line. By going straight through like it was transparent, you'll get the same effect. And the fact that it gets more transparent the faster it's going in the direction you're going makes perfectly good sense, and that would facilitate the drag argument. So you're more likely to get drag, you're more likely to see the drag um, if you complete the, create the dipole and all that kind of crap, it's going to even be more obvious. Yeah, so I think this will work. So it's interesting, you just change one little thing, and you can create a model that might come up with the same results. Very similar. I think might be a better result. I can't say for sure because there's a lot to consider. But it looks like this is probably the right answer. It's looking like it now. At this moment in my life, right? I've had a half hour to think about it, which probably isn't near enough. But I just thought I would say it just because these people are working on models, and I don't want them to unnecessarily waste any extra time, I suppose. And it seems viable for people to think about it. I don't see any fundamental flaw, because it also creates what you want, which is you want this idea that one interaction causes momentum, that is this change in the direction. The other interaction has no effect on momentum, and that's what you want. You want one action to cause action, one action to cause no action, and you still have it very inverse. That is, what causes the green thing to move is exactly the opposite thing from what causes the blue thing to move. And it still keeps that, and then it's true to this principle that the only way you can tell something happens in the universe is two things of a different color have to change their direction. If you have two things of the same color, you can't tell that something happened. And I should have known that that's important. I mean, I wrote it on the website. It was an important fact, the kinetic part of this, and it was an important conversation in the history of these videos. And I should have recognized that the first drawing really wasn't taking that into account. So anyway, I think it's interesting. Food for thought, all that kind of stuff. Not making any for sure statement, just making a maybe. Yeah. So maybe we should have two versions of the simulation, just modify the two and see which one is closer to the actual causes and effects we see. Alright, that should be enough. That's not what I want. That's probably the one I want, so I don't think I need to add anything else to this video. So, yeah, I think that's enough.